The vastness of the universe is often beyond our grasp, a black sea of endless possibilities where mysteries linger, waiting to be unearthed. And then there's 3I Atlas, a comet that has appeared like a shimmering anomaly against the backdrop of space. At first glance, it's just another passing object, a speck in the cosmic dance. But as we track its orbit and gather data, something feels different, something unsettling. Is this comet just an ordinary visitor from the outer reaches of our solar system? Or could it be something much more, something extraordinary? I-Atlas was discovered in October 2019, but it quickly sparked interest far beyond typical astronomical curiosity. As the comet zipped through our corner of the galaxy, it became clear that there was something about its journey, its trajectory, that didn't quite add up. Scientists first considered the usual suspects: an ice ball from the Oort cloud, a distant relic of the early solar system. But the more data they gathered, the stranger it became. Unexplained acceleration, a peculiar shape, a glint of something that wasn't just reflected light. This wasn't just a comet. This was something with a story to tell, if we could only decipher it. As we look deeper, there's an unsettling question that hangs in the air. Could this comet be more than a mere natural object? Could it be proof of something far more extraordinary? Something beyond our wildest imagination? Comet of extraterrestrial origin? An artificial object sent by an unknown intelligence, perhaps? This is the tantalizing, audacious possibility that some scientists and speculators are now daring to explore. The intrigue is compelling. For centuries, comets have been viewed as celestial messengers, harbingers of doom or signs of divine intervention. But the truth is far more complex. While we've become accustomed to studying the cosmos from a strict scientific perspective, we can't help but wonder, what if 3I Atlas is a challenge to our very understanding of the universe? What if it's not just a ball of ice and dust, but a messenger, an ambassador from the farthest reaches of the galaxy or even beyond? Enter the speculative theory. While the mainstream scientific community has largely clung to the belief that 3I Atlas is simply an odd comet, others are taking a different approach, one that dares to question the assumptions of modern astronomy. Could this comet be a probe, an ancient artifact from an alien civilization, or even a sign that we're not alone in the universe? These theories are not just the domain of fringe thinkers. They are being discussed in scientific circles, debated in academic journals, and examined with the same rigor as any other astronomical anomaly. But what do we really know about 3I Atlas? Why is this object so compelling? What makes it different from the hundreds of other comets that have traveled through our solar system? And most importantly, what does it mean for the future of humanity's search for extraterrestrial life? Theories about extraterrestrial life have been with us for centuries. Ancient civilizations wrote of gods descending from the heaven, and modern science fiction has painted an image of alien encounters, some peaceful, others destructive. Yet despite all our speculation, there has been little hard evidence of intelligent life beyond a 3I Atlas could change. To answer the question of whether 3I Atlas is of extraterrestrial origin, we must first understand how we got to this point. For decades, astronomers have been scanning the sky, searching for signs of life, be it in the form of signals, unusual phenomena, or objects that defy explanation. The discovery of Oumuamua in 2017, a mysterious interstellar object that sped through our solar system, began a new chapter in search. The questions it raised were uncomfortable, for they suggested that the universe may not be as empty as we thought, that perhaps there are other forms of intelligence out there, and that we might not be alone after all. When 3I Atlas appeared, the scientific community stood at attention. Was this another Oumuamua, a similar object that had somehow found its way into our cosmic backyard? As we began to track its orbit, we saw that its trajectory was unlike anything we'd seen before. The comet wasn't following a path typical of other solar system bodies. It was accelerating in ways that shouldn't be possible unless an outside force was acting on it. Could this force be from something outside our solar system, an intelligence using the comet as a vehicle of some kind. As the data piled up, so too did the question, could 3I Atlas be a signal, a beacon, or perhaps a warning? As we've explored the vast reaches of space, we've realized that many civilizations, if they exist, might not necessarily be eager to reveal themselves. What if 3I Atlas is a message of sorts, its trajectory and composition designed to make us think, to push us to challenge nature? Is it possible that it's trying to communicate something profound, something we simply aren't equipped to understand yet? This speculative angle is not just some whimsical theory. The notion that advanced civilizations might leave behind artifact, probes, or signs of their existence is grounded in the idea that intelligent life may seek to communicate in ways that transcend the limits of our current understanding. The concept of a technological signature, an artifact, a device, a probe that has traveled across space and time carries with it a tantalizing potential. What if we, at this very moment, are standing at the threshold of a discovery that could rewrite the rules of life in the universe? It is here that science meets philosophy, where the lines between the known and unknown blur, and where speculation and evidence collide. In examining 3I Atlas, we must ask ourselves, what does it mean for us as humans to encounter something that defies easy explanation? Does this challenge our place in the universe? Are we truly as insignificant as we often believe, or is the universe far more intertwined with us than we could ever imagine? As we venture further into the exploration of 3I Atlas, we will delve deeper into the data, the theories, and the possibilities. We'll examine the scientific explanations, both conventional and cutting edge, and juxtapose them with the speculative, daring ideas that challenge everything we know. In doing so, we will not only explore the comet itself, but also confront the deeper questions about our place in the cosmos. Is the universe truly as we see it, or is there something far greater, far stranger, lurking just out of sight? This is just the beginning of the cosmic enigma of 3I Atlas. As we continue our journey, we will push the boundaries of science and imagination, exploring the incredible, awe-inspiring possibilities that this mysterious visitor may hold. What secrets does it carry, and what does it say about the future of human exploration and humanity's search for its place in the cosmos? The discovery of 3I Atlas, a cosmic mystery. In October 2019, a routine scan of the skies by astronomers using the ATLAS Asteroid Terrestrial Impact Last Alert System program, a network designed to detect potential threats to Earth, turned up something unexpected, an object hurtling through the solar system with an unusual trajectory. At first, it was easy to dismiss. After all, astronomers are no strangers to the constant influx of new cosmic discoveries, asteroids, comets, and the occasional rogue body darting through space. Yet something about this new visitor stood out, and it didn't take long for the scientific community to realize that 3I Atlas wasn't just another typical comet. When initial observations showed that the object was moving at an extraordinary speed, a red flag went up. Most comets, when they pass through our solar system, follow predictable orbits influenced by the sun's gravitational pull. But 3I Atlas was different. Its velocity was much higher than expected, far exceeding the normal speeds of known solar system comets. It seemed to be accelerating, moving faster than the gravitational forces of our sun should allow, suggesting that some unknown factor was at play. The data wasn't just intriguing, it was troubling. Initially, the object was classified as a typical comet given its appearance, but scientists quickly found that its motion was far too erratic to be explained by traditional methods. When comets pass through the solar system, they typically experience a gradual acceleration as they approach the sun. This is due to the release of gas and dust from the comet's nuclear, process known as outgassing. But 3I Atlas wasn't behaving like a typical comet. The forces acting on it seemed to be far greater than any outgassing could explain. There was something more to its motion, something that defied expectation. This anomaly raised immediate question: what could be causing the acceleration? Some initially speculated that it could be due to the gravitational influence of a distant planet, an effect known as the flyby acceleration seen in other interstellar objects. But the data didn't line up. As more observations were made, the mystery deepened. 3I Atlas was moving too fast, and its trajectory was too precise to be simply the result of gravitational interaction. Something was pushing it, something unexplained. In the world of astronomy, the unexpected is often met with skepticism. Discovering an object that doesn't fit neatly into established theories is a rare event, and even rarer are those that trigger widespread speculation. The initial reaction from the scientific community was a blend of curiosity and caution. Many astronomers, accustomed to the mundanity of routine comet observations, felt a sense of disbelief. Was this just another fluke, a measurement error, or a miscalculation? After all, comets had been observed for centuries, and most followed predictable paths. The idea that an object could behave outside the known laws of physics was a radical thought. Yet as more data poured in, skepticism began to give way to intrigue. As astronomers continued to track its trajectory, the true strangeness of 3I Atlas became undeniable. The object didn't follow a predictable arc as it passed through the solar system. Its path seemed to curve unnaturally, taking it on an orbit that was completely at odds with any known cometary behavior. This was not a simple cosmic wanderer, this was something with purpose. As a result, 3I Atlas began to attract the attention of researchers beyond the usual circles of cometologists and planetary scientists. At this point, the narrative of 3I Atlas shifted. What had been an ordinary discovery became a subject of intense debate. As scientists combed through the data, they began to wonder, was this object truly just a comet, or could it be something else, something artificial? Could this be an object that didn't just belong to our solar system, but had traveled here from elsewhere in the galaxy, or even further? The contrast between the scientific method and the allure of the unknown is particularly striking in the case of 3I Atlas. In scientific research, questions are typically approached with a healthy dose of skepticism, and hypotheses must be supported by evidence before they are taken seriously. Yet the evidence in the case of 3I Atlas was so peculiar that it compelled a shift in thinking. Was the object's strange movement an anomaly caused by factors we hadn't yet considered, or was it something that fundamentally challenged our understanding of what comet or even interstellar object could be? It's this tension between the known and the unknown, the mundane and the extraordinary, that fuels the fascination with objects like 3I Atlas. Every new discovery is an opportunity to expand our understanding of the universe, but every anomaly, every unexplained phenomenon forces us to confront the limitations of that understanding. The discovery of 3I Atlas didn't just challenge our assumptions about comets, it challenged the very notion of what's possible in space. While many scientists continued to pursue more conventional explanations, there was an undeniable undercurrent of excitement in the speculative theories surrounding 3I Atlas. Was it possible that this object, with its erratic trajectory and unexplained speed, was something far more profound? Could it be an interstellar artifact, an ancient probe, or a ship launched by an advanced civilization? These ideas weren't entirely far-fetched. The discovery of Oumuamua just 2 years earlier had already thrown the scientific community into disarray with its own strange behavior and improbable origin. If Oumuamua was the first of its kind, then 3I Atlas could be the second and even more enigmatic visitor from the stars. For those willing to entertain more radical ideas, 3I Atlas became a symbol of the mystery and wonder that lies at the frontier of scientific discovery. It wasn't just a comet, it was a riddle, a cosmic puzzle, and in many ways it embodied the intersection between the known and the unknown, where science and imagination could collide. Whether or not it was of extraterrestrial origin was secondary to the fundamental question it raised. What are we truly looking for in the universe? Are we merely trying to understand the mechanisms that govern the cosmos, or are we hoping to find something or someone that challenges our very place in it? The discovery of 3I Atlas may have begun as a simple observation of a new comet, but it quickly evolved into a cosmic mystery. It drew attention not just from astronomers, but from scientists of all disciplines, from physicists to philosophers, all intrigued by the unanswered questions it raised. With each new observation, the possibility that 3I Atlas was something more than a comet became harder to ignore. Could it be the key to unraveling deeper mysteries of the cosmos, or was it simply another unexplained anomaly that would fade into obscurity like so many before it? As we continue to explore the true nature of 3I Atlas, we must confront the age-old tension between skepticism and wonder, science and speculation. In doing so, we might just be on the cusp of answering one of the greatest questions humanity has ever asked. Are we alone in the universe? The scientific community continues to track 3I Atlas, scrutinizing every piece of data, every shift in its trajectory, every anomaly that surfaces. But no matter how much we learn, the mystery of this comet will continue to haunt us, pushing us to look beyond the star and wonder what lies in the darkness, waiting to be discovered. Comet or something more? The case for extraterrestrial origin. When 3I Atlas was first discovered, it seemed to fit neatly into the category of a typical comet, an icy wanderer from the outer reaches of the solar system, a relic from the early days of our cosmic neighborhood. But as astronomers tracked its path and observed its behavior, a different picture began to emerge. The comet's hyperbolic trajectory, its inexplicable acceleration, and its unusual shape all suggested that 3I Atlas might not be just another run-of-the-mill cosmic visitor. Could it be something far more extraordinary, something engineered, perhaps an artificial object intentionally sent by an advanced extraterrestrial civilization? The idea is audacious, but it raises profound questions about the nature of the universe and our place within it. At the heart of this theory lies a series of unexplained anomalies in the comet's motion. Comets are typically governed by the laws of celestial mechanics, dictated by the gravitational pull of the sun and the forces acting on their icy core. As they approach the sun, they begin to warm, shedding gas and dust, and creating the iconic tails we see in telescopic images. But 3I Atlas did not behave as expected. Despite being at a distance where comets typically slow down, this object was speeding up. What was driving this acceleration? It wasn't the sun's gravity alone. There had to be another force at play, one that didn't conform to the natural laws we thought we knew. The hyperbolic trajectory of 3I Atlas is another compelling aspect of the mystery. Most comets follow elliptical orbits, looping around the sun before returning to the far reaches of the solar system. However, 3I Atlas was different. Its path was hyperbolic, meaning it wasn't bound by the sun's gravity at all. This object was traveling on a one-way trajectory, an interstellar journey that suggested it was passing through our solar system without any intention of returning. It seemed to be moving too fast to be just a random object caught in the sun's gravitational web. Its speed, direction, and behavior seemed calculated, intentional even. This deviation from the norm led to a tantalizing possibility. 3I Atlas wasn't just a comet. It could be an interstellar probe. If an advanced civilization had sent it, perhaps it was gathering data, or maybe it was a message, a sign of life beyond our understanding. The idea that we might not be alone in the universe is one that has fascinated humans for centuries, from the myths of ancient civilizations to the futuristic dreams of space explorers. But here, in the form of 3I Atlas, we might have something that could provide tangible evidence if we are willing to look beyond the conventional scientific explanation. While the idea of extraterrestrial probes may sound like the stuff of science fiction, it is not without precedent. The discovery of Oumuamua in 2017, another interstellar object, sparked similar debate. Like 3I Atlas, Oumuamua exhibited unusual characteristics that defied simple explanation. Its elongated shape, erratic motion, and unexplained acceleration led some scientists to entertain the idea that it might be an artificial object, possibly a probe sent by an alien civilization. While most researchers dismissed this theory, the mere fact that it was entertained opened the door to further speculation. Could 3I Atlas be another example of such a phenomenon? Was it possible that we were witnessing the arrival of a message from beyond the stars? To support the theory that 3I Atlas might be an artificial object, proponents point to several key pieces of evidence. The object's speed is one of the most compelling. As it passed through our solar system, it was moving far faster than any known comet, even those from the distant Oort cloud. The acceleration acceleration it exhibited, which could not be fully explained by the sun's gravitational pull, suggested that something else was at work, perhaps a propulsion system, an unseen force guiding its path. Some have even speculated that 3I Atlas could be powered by an advanced form of technology, possibly a type of solar sail, a concept where large, reflective surfaces are used to harness the energy of a star and propel a spacecraft. Such a technology could explain the strange behavior of 3I Atlas, its acceleration, its speed, and its trajectory. Another fascinating angle is the object's unusual shape. While traditional comets are irregular, icy chunks of rock, 3I Atlas has been observed to exhibit a surprisingly flat, elongated form, almost like a thin cigar. Could this be a sign of artificial design? The distinct shape is unlike anything we would expect from a typical comet, which are generally more spherical or irregularly shaped due to their formation in the icy outer regions of the solar system. The idea that 3I Atlas could be an alien craft or a piece of alien technology is supported by this strange configuration. What if this object is designed to maximize efficiency in its journey through space, perhaps reflecting light in a way that we don't yet understand, or using its shape to interact with cosmic radiation in some unknown manner? Visualizing this alien technology might look like adds another layer to the mystery. Imagine an object traveling through space, propelled by an advanced energy source, its smooth, reflective surface gleaming as it catches the light of distant stars. The shape, like a sleek, elongated blade, glides silently across the universe, carrying with it a message or perhaps a mission. Its design is unlike anything humanity has ever conceived, a sophisticated engineering marvel that seems to stretch the limit of our imagination. This is where the speculative side of the theory comes into play. While the scientific community remains largely skeptical, the idea that 3I Atlas could be an extraterrestrial probe invites us to think beyond our current understanding of physics and technology. Could this object be a small part of a much larger puzzle? What if it's just the first of many, sent by civilizations far older and more advanced than ours, scattered across the galaxy, monitoring or exploring other worlds, just as we are now doing with our own space probe? For those who entertain these possibilities, the question becomes, if 3I Atlas is indeed artificial, then what does that mean for humanity? Could it be proof that intelligent life exists beyond Earth and that we are not the only conscious being
in the universe? Or is it simply a product of our own need to meaning? If it is an alien probe, what message is it?
Or perhaps it's a signpost, a marker, left by an ancient civilization to guide us towards something greater, a call for us to reach out and explore the stars. But not everyone is convinced. The scientific community has largely dismissed the idea of 3I Atlas being an alien probe, often citing the lack of concrete evidence and the dangers of jumping to conclusion. While the anomalies in its trajectory are certainly puzzling, many scientists argue that there are natural explanations, perhaps an as-yet undiscovered force at play, or even the possibility of a new physical principle that we haven't yet understood. After all, space is vast, and the laws that govern it may be more complex than we can currently imagine. Despite the skepticism, the theory that 3I Atlas could be an artificial object, possibly a probe from an alien civilization, remains one of the most captivating ideas surrounding this cosmic mystery. Whether it is the product of natural forces or the result of intelligent design, 3I Atlas has captured the imagination of millions, challenging us to reconsider everything we thought we knew about the cosmos. The search for answers continues, and with each new discovery, we move closer to uncovering the true nature of this enigmatic visitor, decoding the trajectory, the physics behind 3I Atlas. When 3I Atlas was first discovered, astronomers quickly noted its unusual trajectory, one that set it apart from the hundreds of comets that pass through our solar system every year. Most comets are caught in the gravitational pull of the sun, following elliptical orbits that predictably loop around our star before returning to the distant reaches of space. But 3I Atlas was different. Its path was hyperbolic, a trajectory that would not return it to the sun, suggesting it was passing through the solar system on a one-way trip, an interstellar wanderer. This unexpected orbital behavior immediately raised red flags, prompting astronomers to take a closer look at the physics driving its journey. The concept of a hyperbolic orbit isn't new in astronomy, but it's rarely seen in practice. When when objects in space are in hyperbolic orbit. They are not bound to the sun's gravity. They are simply passing through the solar system, never to return. Hyperbolic trajectories typically occur when a body, such as an asteroid or comet, comes in from outside the solar system, grazes the sun, and then exits on a path that doesn't bring it back. The most famous example of this is Oumuamua, the first known interstellar object to pass through our solar system, which similarly displayed an unusual trajectory and sparked widespread speculation. What makes 3I Atlas particularly intriguing, however, is not just that it followed a hyperbolic path, but that its speed and movement did not conform to the typical expectations for such objects. When comets approach the sun, the heat causes them to release gas and dust, a process known as outgassing. This releases energy and creates a force that pushes the comet in the opposite direction. The result is a gradual acceleration as the object nears the sun. This is what allows comets to develop their characteristic tail. However, 3I Atlas didn't behave this way. The acceleration of 3I Atlas was not entirely explained by outgassing. Its trajectory seemed to bend, as if an unseen force was acting upon it. The object's velocity was far greater than that of any known comet, and its speed didn't decrease as expected. Instead, it accelerated as it moved farther away from the sun. According to the laws of physics, this should not have happened. As a comet moves away from the sun, its rate of acceleration should naturally decrease as the sun's gravitational pull weakened. Yet 3I Atlas appeared to be propelled forward with a force that scientists couldn't immediately explain. This led to one of the most profound questions surrounding its trajectory. What force was responsible for this unnatural acceleration? The most straightforward explanation was the one many scientists initially settled on: outgassing. Perhaps, despite its distance from the sun, 3I Atlas was still shedding gas and dust at an accelerated rate, pushing it forward. However, as astronomers continued to track the comet's path and gather data, they found that the outgassing theory could not account for the extent of the comet's acceleration. The rates of outgassing required to produce the observed changes in speed were far beyond what was typically seen in comet. Furthermore, the shape of 3I Atlas, an elongated cigar-like form, did not seem conducive to the uniform outgassing seen in most comets, which tend to be irregular or spherical. This led to a deeper question. Could there be another factor at play? One possibility that gained traction was the idea that 3I Atlas was interacting with a force that we don't fully understand, a type of energy, perhaps from an unknown cosmic source, that was pushing the object forward. This led some to speculate that 3I Atlas could be influenced by something artificial. Could it be that the object's trajectory was the result of a form of propulsion, perhaps a solar sail or a piece of alien technology acting on the object in ways that defied conventional explanations? To better understand these forces, scientists turned to more advanced models of physics. One avenue of investigation was the concept of solar radiation pressure. Solar radiation pressure occurs when light from the sun exerts a force on objects in space. This force is tiny, but over vast distances and over long periods of time, it can have a significant impact on the movement of objects. Some theorists suggested that 3I Atlas could be exhibiting this behavior as light from the sun pushes against its surface, possibly aided by the object's shape. The elongated, flat form of the comet could be ideal for reflecting sunlight, causing it to be propelled in ways that other, more spherical objects could not. Another hypothesis that arose from the data was the possibility of gravitational anomaly. The sun, despite its massive influence, is not the only gravitational force in the solar system. Other celestial bodies, particularly massive planets like Jupiter, exert a considerable gravitational pull. Could 3I Atlas have been affected by the gravity of one of these planets as it passed through the solar system? Some scientists argued that it was possible that the comet's unusual trajectory was the result of a complex gravitational interaction involving not just the sun but other planets as well. However, this theory did not fully account for the object's accelerating speed and continued to leave scientists with more questions than answers. As the mystery deepened, the contrast between established science and the unexplainable nature of Three-Eye Atlas became even more apparent. On one hand, scientists could apply known principles of physics to explain much of what was happening. On the other hand, the anomalies surrounding Three-Eye Atlas challenged those very principles. The object's acceleration, its hyperbolic trajectory, and its strange shape didn't fit neatly into any established model of comet behavior. This created a fascinating paradox. While conventional science could explain much of the object's motion, it couldn't fully account for the unusual features that made Three-Eye Atlas so intriguing. The debate over the true nature of Three-Eye Atlas highlights a broader tension within the scientific community between skepticism and wonder, certainty and mystery. The scientific method is built on the idea of observation, data collection, and theory development. But when confronted with phenomena that defy explanation, the scientific community must walk a fine line. Should they continue to refine existing models, or is it time to reconsider the very laws of physics that have guided our understanding of the universe for centuries? While many scientists remain cautious, insisting that Three-Eye Atlas is simply an anomaly that can be explained by known forces, others argue that the evidence points to something far more extraordinary. If the object's behavior cannot be explained by the laws of physics as we understand them, then it may be time to consider alternative explanation. Could Three-Eye Atlas be a cosmic messenger, a probe from an advanced civilization, or even a sign that we are on the cusp of discovering something profoundly new about the universe? In the end, the trajectory of Three-Eye Atlas is more than just a puzzle. It is a window into the limits of human knowledge. It forces us to confront the boundaries of science and the unknown. As we continue to gather data and refine our model, we must ask, what is the true nature of the forces acting on Three-Eye Atlas? Are we witnessing the work of natural forces, or is something far more mysterious at play? The answer to these questions may unlock new frontiers in physics and in our understanding of the cosmos itself. Oumuamua, the precedent for alien theory. The discovery of Three-Eye Atlas in 2019 wasn't the first time that astronomers encountered an object from outside our solar system that defied conventional explanation. Just 2 years earlier, in 2017, a mysterious interstellar object named Oumuamua passed through our solar system, sparking a wave of speculation about extraterrestrial intelligence. Oumuamua's unusual characteristics raised questions that no one had seriously considered before. Could this be the first tangible evidence of alien technology? Like Three-Eye Atlas, Oumuamua displayed strange behavior that defied the known laws of physics. The object, which was first identified by astronomers at the Pan-STARRS 1 telescope in Hawaii, was unlike anything seen before. It was long and cigar-shaped, rotating rapidly as it hurtled through space. Its path was hyperbolic, similar to Three-Eye Atlas, suggesting that it too was not bound by the sun's gravity and was on a one-way trip through the solar system. These characteristics alone set Oumuamua apart from any comet or asteroid observed before. But what truly raised eyebrows was the unexplained acceleration it exhibited as it passed through our solar system. Typically, objects that enter our solar system, such as comets and asteroids, experience acceleration due to the sun's gravitational pull. When comets approach the sun, they heat up, releasing gas and dust in a process called outgas, which also generates a thrust that pushes the comet forward. However, Oumuamua did not display the typical signs of outgas. There was no visible tail, no significant increase in brightness that would indicate the release of material. Despite this, it accelerated in a way that couldn't be explained by gravity alone. Some scientists speculated that the acceleration could be the result of radiation pressure from the sun or the action of an unknown force, but no clear explanation emerged. As a result, the object became the subject of intense debate, especially when some outlier theories suggested that Oumuamua might be an artificial object, perhaps a probe sent by an advanced alien civilization. Fast forward to 2019 and Three-Eye Atlas enters the scene, and immediately the comparisons between the two objects became unavoidable. Both came from outside the solar system. Both followed hyperbolic trajectories, and both exhibited acceleration that couldn't be fully explained by the conventional laws of physics. As astronomers began to track 3I Atlas's path, the similarity to Oumuamua were hard to ignore. Just like its predecessor, 3I Atlas displayed behavior that was inconsistent with what we would expect from a typical comet. It was moving at an extraordinary speed, accelerating unexpectedly, and following a trajectory that suggested it wasn't bound to the Sun in any meaningful way. The contrast between these two objects' trajectories was subtle but significant. While Oumuamua's acceleration seemed to be driven by a force acting on its surface, possibly radiation pressure or an unknown cosmic influence, 3I Atlas's behavior pointed to something different. The comet's anomalous acceleration was not explained by any of the traditional forces that govern comet. Its shape, a long, thin, cigar-like form, added to the speculation that it could be an artificial object, much like the theories surrounding Oumuamua. Both objects seem to defy the known laws of nature, raising the same uncomfortable question. Could these be alien artifacts, probes sent by advanced extraterrestrial civilization? This idea, while fascinating, is still met with skepticism by the majority of the scientific community. Mainstream astronomers have largely dismissed the possibility that either Oumuamua or 3I Atlas could be artificial. In fact, many argue that there are still natural explanations for the anomalous behavior of both objects. For Oumuamua, some have suggested that it could have been a fragment of a larger body that was ejected from a distant star system, and its acceleration could have been caused by the effects of sunlight or the gravitational interactions with nearby stars. In the case of 3I Atlas, the scientific consensus leans toward explanations involving outgassing or unknown physical processes rather than alien intervention. Despite the conventional explanations, the idea that both objects could be evidence of extraterrestrial intelligence continues to attract attention, particularly from researchers who specialize in the search for alien life. Avi Loeb, an astrophysicist from Harvard University, is one of the most prominent advocates for the theory that Oumuamua might be an alien probe. He suggests that the object's unusual speed shape could be consistent with a piece of technology, perhaps a solar sail sent by an intelligent civilization. Loeb's hypothesis, though controversial, has sparked a wider conversation about the possibility that advanced civilizations might communicate with us through deliberately sent probes or artifacts rather than through direct contact or signal. For those who entertain this theory, the similarities between Oumuamua 3I Atlas only strengthen the case. Both objects, with their strange behavior and unexplained acceleration, represent an opportunity to challenge the assumption of conventional science and to think outside the box. Could these be the first pieces of evidence of alien technology sent from across the galaxy to observe us, or perhaps to send us a message? The idea that intelligent life exists beyond Earth is a deeply philosophical one, and the implication of such a discovery would be nothing short of transformative for humanity. Yet the scientific community remains divided. For many, the idea of alien probes is a leap too far. The data from Oumuamua and 3I Atlas are intriguing, but they do not provide the smoking gun that would prove the existence of extraterrestrial intelligence. After all, the universe is vast, and the anomalies we see could easily be the result of natural processes that we don't yet fully understand. Perhaps the acceleration of Oumuamua was the result of an unknown physical force, or perhaps the strange behavior of 3I Atlas can be explained by a combination of gravitational interactions and the comet's unusual shape. As we consider the implications of these two objects, we must remember that science is a discipline grounded in skepticism and evidence. Theories must be supported by data before they can be accepted as truth. And while the possibility of extraterrestrial intelligence remains tantalizing, it is important not to rush to conclusions without further evidence. For now, the debate surrounding Oumuamua and 3I Atlas remains open, with no definitive answer in sight. These objects have pushed the boundaries of our understanding of the cosmos, and whether they are signs of alien life or simply anomalies in space, they continue to challenge us to think more deeply about our place in the universe. The question of whether Oumuamua and 3I Atlas are evidence of extraterrestrial probes remains unanswered, but one thing is certain: both objects have changed the way we think about the cosmos. They have forced us to confront the possibility that we may not be alone in the universe, and that our search for life beyond Earth may one day yield results that we can't yet imagine. For now, the enigmatic visitors from the stars remain a mystery, one that beckons us to explore further, to push the boundaries of science and imagination, and to remain open to the possibility that we are just beginning to understand the vastness of the universe. The technology behind space. Could 3i Atlas be a visitor? The notion that 3i Atlas could be an interstellar probe sent by an advanced civilization from a distant star system is both exhilarating and perplexing. To entertain such an idea, we must first explore the nature of space probe, the technology behind them, and the speculative possibilities for what an alien probe might look like. Given that humanity has only just begun to send probes beyond our solar system, the concept of extraterrestrial probes presents a profound question. How could an alien civilization, potentially millions of years ahead of us, design a spacecraft capable of interstellar travel? And if such technology exists, could it be that 3i Atlas, one such visitor, an artifact from a civilization far older than our own? Human space probe technology. Before delving into the hypothetical, it's important to establish what we know about human-made space probes and how they operate. Since the 1960s, humanity has sent numerous spacecraft to explore our solar system and beyond. Some of the most notable space probes include NASA's Voyager 1 and 2, which were launched in the 1970s with the goal of reaching interstellar space. Voyager 1 is currently the most distant human-made object from Earth, and it is expected to continue transmitting data back to Earth for several more years, though its power sources are running low. These probes, however, are far from perfect examples of interstellar travel. Human probes are limited by several factors, including their propulsion system, energy sources, and the immense distances involved in interstellar space travel. Voyager 1, for example, is powered by nuclear batteries, which have a finite lifespan, and its speed is slow by the standards of interstellar travel. Even at its current speed, around 17 kilometers per second, it would take over 70,000 years for Voyager 1 to reach the nearest star system, Alpha Centauri, located 4.37 light-years away. Despite these limitations, human space probes provide insight into the practical challenges of long-distance space travel. They rely on chemical propulsion system, gravity assist, and nuclear power, all of which are effective within the confines of our solar. However, none of these technologies are suitable for sending probes to other star systems, where distances are measured in light years and the time frames involved are on the order of thousands, if not millions, of years. Hypothetical alien probe technology. Given the vast technological gap between our current capabilities and the requirements of interstellar travel, one might wonder, how could an advanced civilization overcome these limitations? If 3i Atlas is indeed a probe sent from another star system, its design and propulsion mechanisms would likely be far beyond anything we can currently conceive. One possibility that has been proposed is the use of solar sail, an elegant and potentially practical solution for interstellar travel. Solar sails are large, lightweight, reflective surfaces that use the pressure of starlight to propel a spacecraft through space. Unlike chemical propulsion, which relies on expelling mass at high velocity, solar sails harness energy from the sun or any other star by reflecting photons off the surface of the sail, creating a continuous push. Over vast distances, this gradual force could accelerate a spacecraft to a significant fraction of the speed of light. In theory, solar sails could carry a spacecraft across interstellar distances within a human lifetime. For instance, if a solar sail were launched towards the nearest star system, Proxima Centauri, it could reach there in just a few decades, provided the sail is large enough and the technology is sufficiently advanced. A solar sail does not require fuel, which makes it an appealing option for long-term space exploration. If 3i Atlas is a solar sail, it would explain its apparent acceleration. As the object moves further from the sun, the star's light would continue to push it forward. The challenge of long-distance travel. While the solar sail hypothesis is an exciting possibility, it still raises significant questions. One of the most pressing is the challenge of navigating vast distance. Even at the speed of light, the nearest star system is over 4 light-years away, and even if 3i Atlas traveling at a fraction of that speed, its journey would still take hundreds to thousands of years. How could an alien civilization have launched such a probe knowing it would take so long to reach its destination? One possible solution is that these civilizations may have mastered artificial intelligence, AI, and autonomous systems to a degree that allows probes like 3i Atlas to function without constant human oversight. An AI-driven probe could be designed to operate for millennia, making decisions on its own, navigating interstellar space, and performing its mission without any direct communication from its creators. Such an approach would explain how a probe could travel for such long distances without human intervention. Another idea is that the probe may have been launched eons ago, possibly as a relic of a long-gone civilization. Ancient civilization might have sent out fleets of probes to explore the stars, and over time, these artifacts have continued their journey, drifting through the cosmos like ancient relics. If 3i Atlas is indeed one of these long-lost probes, it would be the first sign that we are not the only one to have pondered the mysteries of the universe. This raises a profound philosophical question. If advanced civilizations once existed, what happened to them? Did they self-destruct, or did they move on to other dimensions, leaving behind their machines to wander the stars? A universe filled with visitors? If probes like 3i Atlas exist, they could be the first of many that humanity may one day encounter. The idea that the universe is filled with ancient artifacts from long-lost civilizations challenges our perception of time and space. It suggests that we are not the first, nor will we be the last to explore the cosmos. In this scenario, the galaxy is not empty, but teeming with relics of intelligent life, each one carrying with it a piece of the story of its creators. Perhaps scattered across the stars, there are other probes, silent, unblinking, waiting for us to find them. Such a vision of the universe challenges the traditional view of space as an empty void. Instead, it suggests that we may be on the verge of discovering a galaxy brimming with the remnants of civilizations far older and more advanced than our own. The implication of such a discovery would be staggering. Not only would it confirm that we are not alone in the universe, but it would also force us to rethink our place in the cosmos. Are we the first intelligent beings to have emerged in the galaxy, or are we merely one chapter in a much larger, more complex story? The feasibility of alien technology. While the idea of interstellar probes is compelling, the technology required to send such missions presents enormous challenges. Even if an advanced civilization were capable of building probes like 3i Atlas, the energy requirements would be immense. One solution might be the development of fusion propulsion, a technology that harnesses the power of nuclear fusion to generate incredibly high speed. Fusion propulsion, though still theoretical, could theoretically enable spacecraft to reach a significant fraction of the speed of light, making interstellar travel more feasible. Alternatively, advanced civilizations may have discovered entirely new methods of propulsion that are beyond our current understanding. The possibilities are as vast as the imagination itself, but one thing is certain: if 3i Atlas is indeed an interstellar probe, it would be the result of a technological leap that dwarfs our current spacefaring capabilities. For humanity to follow in such footsteps, we would need to overcome challenges that are currently insurmountable. Are we ready for the truth? The idea that 3i Atlas could be an interstellar probe is a fascinating one, but it forces us to confront the limits of our technological imagination, the challenges of long-distance space travel, the potential for alien technology, and the question of whether the universe is filled with ancient artifacts all challenge our understanding of the cosmos. But perhaps in contemplating these questions, we are not only considering the possibility of extraterrestrial visitors, we are also exploring the future of humanity's own quest to reach the star. As we continue to push the boundaries of our space exploration efforts, we must ask ourselves, what if 3i Atlas is just the beginning? What if one day we too will send probes to distant star systems to wander the cosmos in search of answers, just as as other civilizations may have done long before. In doing so, we may find that the universe is not as empty as it appears, but a vast, interconnected web of intelligence and discovery waiting to be explored. The search for extraterrestrial life, SETI and beyond. For centuries, humanity has looked to the stars, asking the profound question, are we alone in the universe? The search for extraterrestrial life has evolved from speculative myth and ancient lore into a structured scientific endeavor. At the forefront of this pursuit is the Search for Extraterrestrial Intelligence, SETI, a program dedicated to detecting signals from alien civilization. While SETI represents a rigorous, evidence-based approach to the question of alien life, the discovery of objects like 3I challenges the scientific boundaries, introducing a layer of speculation about extraterrestrial visitation that cannot be so easily tested, proven. This tension between the precise methods of SETI and the intriguing, unprovable theories of alien encounters is at the heart of the search for extraterrestrial life today. The SETI program, a systematic approach. The SETI program, established in the 1960s, remains one of humanity's most ambitious and focused efforts to detect intelligent life beyond Earth. SETI's approach is built on the search for electromagnetic signals radio wave, in particular emitted by extraterrestrial civilization. The logic behind this search is simple. Advanced civilizations capable of interstellar communication would likely use radio waves to transmit information, just as humanity has begun to do with its own space probe. SETI operates through radio telescopes that scan the sky for unusual signals, specifically looking for patterns that would indicate an artificial source. This method, although direct and measurable, is constrained by one significant challenge: the vastness of space. The probability of detecting a signal from another civilization is astronomically small, as signals need to travel vast distances to reach us. Furthermore, the nature of any signals, whether they would be intentional, powerful, enough, or even compatible with our technology, remains entirely speculative. Despite these challenges, SETI has made significant strides using advanced technology to scan millions of star systems for signs of alien life. Its most famous success, the detection of the WOW signal in 1977, remains an intriguing mystery. However, no definitive proof of extraterrestrial intelligence has yet been found. The rise of astrobiology, looking for life, not just intelligent. While SETI focuses on the search for intelligent civilization, the broader field of astrobiology has expanded the scope of inquiry to include the search for life in all its forms, not just sentient being. Astrobiologists study the conditions necessary for life, searching for chemical signatures and environmental conditions that might support microbial life on other planets and moons. This field has gained tremendous momentum, particularly with the discovery of planets orbiting stars outside our solar system that may have the right conditions for life as we understand it. The discovery of extremophiles on Earth, organisms that thrive in extreme conditions like deep-sea vents or acidic lakes, has broadened our understanding of where life might exist beyond Earth. Planets and moons previously thought to be inhospitable, like Mars, Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are now considered promising candidates for microbial life. These discoveries shift the question of extraterrestrial life from the realm of science fiction to the realm of possibility, suggesting that life may not be as rare or extraordinary as we once thought. Astrobiology, however, is still in its infancy. The detection of life, even microbial, on another planet would be one of the greatest scientific achievements in history. Yet, even as technology advances, we remain limited by the vast distances between star systems and the lack of definitive methods to detect distant life form. Instruments like the James Webb Space Telescope, which will be able to study the atmosphere of exoplanets for signs of habitability, offer hope, but the search is still in its early stages. The speculative nature of alien visitation, in contrast to the scientific rigor of SETI and astrobiology, the idea that 3I could be a visitor from another civilization presents a more speculative speculative scenario, one that is far more difficult to test prove. Unlike the search for signals or chemical traces, the theory that 3i Atlas is an artificial probe requires us to entertain the possibility of extraterrestrial civilizations that are either technologically far beyond us or whose methods of communication and exploration are radically different from anything we can imagine. The data we have about 3i Atlas, a hyperbolic trajectory, unexplained acceleration, and an anomalous shape cannot be measured or replicated in a laboratory. It raises questions that cannot be answered with our current scientific tool. This speculative nature places theories about 3i Atlas in stark contrast with the methods of SETI, which focuses on detecting concrete, verifiable signals. The idea that 3i Atlas could be an alien probe rather than a natural comet is difficult to reconcile with our understanding of science. It challenges the premise of evidence-based inquiry by introducing a theory that cannot be conclusively tested or disproven. For many, this is the allure of such theories. They stretch the boundaries of what we know, introducing the tantalizing possibility that we might not be alone in the universe. But the lack of concrete evidence, combined with the speculative nature of the theory, creates a barrier to widespread acceptance within the scientific community. What if alien life exists? The search for extraterrestrial life, whether through SETI's radio signals or astrobiology's hunt for microbial life, has been motivated by a single question. If alien life exists, what does it mean for humanity? The implications are profound. On a scientific level, the discovery of alien life would revolutionize understanding of biology, physics, and the nature of the universe. It would suggest that life is not unique to Earth, but a common phenomenon across the cosmos, changing our view of life itself and our place in the vast expanse of space. On a philosophical level, the discovery of intelligent extraterrestrial life, or even the possibility of contact, would force humanity to reconsider its position as the dominant species in the cosmos. It would challenge our assumptions about human exceptionalism, our place in the hierarchy of life, and even our ethical obligations to other intelligent beings. Could we, as a species, accept that other civilizations might have existed long before us? And if they are still out there, what would it mean for our future? Would contact lead to cooperation or conflict? The idea of alien life forces us to confront the possibility that the universe is far more complex and interconnected than we ever imagined. Furthermore, the discovery of extraterrestrial intelligence would likely have profound cultural and societal consequences. How would religions, philosophies, and worldviews shift in response to the realization that we are not alone? How would humanity's future goals change if we knew that advanced civilizations were out there, waiting to be discovered or perhaps contacted? The paradox of the unknown. Despite the fervent searches conducted by SETI, astrobiology, and space agencies, we have yet to find definitive proof of alien life. Yet, as we look at the anomalies presented by objects like 3i Atlas, we are reminded of the tantalizing possibility that alien life may already be knocking at our door. The paradox is this: the search for extraterrestrial life is rooted in the belief that one day we will find definitive proof, but in the absence of that proof, we are left to consider the unknown, the unexplained, and the speculative. As 3 Atlas passes through our solar system, it stands as a symbol of this paradox, an object that might be a message from the stars or perhaps a natural anomaly. In the end, the search for extraterrestrial life is as much about the journey of discovery as it is about the answers we hope to find. Whether we are looking for microbial life on a distant exoplanet or trying to understand the behavior of mysterious interstellar objects, the ultimate question remains the same. What does it mean for humanity if we are not alone? A new frontier in astrophysics, the discovery of interstellar objects 3i Atlas, has expanded the boundaries of our understanding of the cosmos in ways that were once the domain of science fiction. For decades, we viewed our solar system as a self-contained, isolated entity, our sun surrounded by planets, moons, and a scattering of asteroid Comet, but the detection of Three-Eye Atlas in 2019 and the earlier discovery of Oumuamua has forced scientists to reconsider this view. These objects coming from beyond our solar system suggest that our local neighborhood is part of a far larger and more interconnected universe than we ever imagined. They raise questions that go beyond the nature of individual objects and challenge our understanding of astrophysical, gravitational dynamics, and the very structure of the galaxy itself. The significance of interstellar objects. Interstellar objects are, as their name suggests, visitors from other star systems, rare, fleeting visitors to our solar system that have traveled across vast stretches of space. Prior to 2017, when Oumuamua passed through our solar system, no such object had ever been observed. We were unaware of the possibility that objects could enter our solar system from outside the gravitational influence of the Sun. The discovery of Oumuamua and later Three-Eye Atlas opened an entirely new chapter in our understanding of the cosmos, signaling that the universe is far more interconnected than previously thought. Unlike asteroids and comets that are bound to the Sun's gravity, interstellar objects do not follow the familiar orbits that govern the rest of our solar system. Their hyperbolic trajectories suggest that they are simply passing through on their way to other regions of space. For centuries, astronomers had assumed that the solar system was isolated, with its objects gravitationally tethered to the Sun. But these interstellar travelers defy this notion, showing that the solar system is part of a much larger dynamic environment, a galactic neighborhood with boundaries that are less defined than we ever imagined. A new astrophysical model, the existence of interstellar objects, requires us to rethink established astrophysical models. For one, it challenges our understanding of the Oort cloud, the theoretical cloud of icy bodies that is believed to surround our solar system and act as a reservoir for comets. Traditionally, the Oort cloud was thought to be the outermost boundary of our solar system, marking the limit of the Sun's gravitational influence. But interstellar objects like Three-Eye Atlas show that the solar system's boundary may not be so well defined. These objects travel freely through interstellar space, entering and exiting our solar system without being bound by its gravity. The discovery of these interstellar visitors suggests that the Sun's gravitational influence extends far beyond the Oort cloud into the broader interstellar medium. It opens up new questions about the interactions between our solar system and the rest of the galaxy. Are these objects rare, or is the galaxy filled with interstellar travelers constantly passing through the solar systems of other stars? Could our solar system be a common stop on a galactic highway of cosmic traffic? These questions push the limits of our current astrophysical models and suggest that the solar system is not an isolated island, but part of a much larger and more active universe. Gravitational dynamics and the Milky Way, the entry of interstellar objects into our solar system, also highlight the complexity of gravitational dynamics. In the traditional view, comets and asteroids that pass through the solar system are controlled by the Sun's gravity, and their movements are predictable based on known laws of celestial mechanics. But when objects like Three-Eye Atlas are observed, their movement becomes much more difficult to explain. Atlas's hyperbolic trajectory, for example, is a clear indication that its motion is not influenced solely by the Sun's gravity. As an object moving at speeds far greater than typical comet, Three-Eye Atlas defies easy categorization. The fact that its trajectory was not circular or elliptical, as is typical for objects in our solar system, suggests that it might not have been influenced by the Sun at all, or that another force, a force we don't fully understand, was acting on it. This opens up the possibility that objects like Three-Eye Atlas may not be subjected to the same gravitational rules as those from our solar system. The presence of these objects challenges our understanding of gravitational dynamics, pushing us to consider the influence of other forces or phenomena that we have yet to detect. Could there be unseen forces operating at vast distances guiding these objects along their path? The scientific community is only beginning to scratch the surface of these questions. The interconnected universe implication for our understanding of the cosmos world. Perhaps the most profound implication of the discovery of interstellar objects is the idea that the universe is far more interconnected than we once believed. We have long understood that our solar system is part of the Milky Way galaxy, but until the discovery of objects like 3I Atlas, our understanding of how our solar system fits into the larger galactic landscape was limited. The passage of interstellar objects suggests that the galaxy is filled with travelers, cosmic wanderers that traverse vast distances, crossing the space between stars, planets, and even galaxies. This understanding radically changes the way we view the structure of the universe. If interstellar objects are not rare, but rather a common feature of galactic life, then the universe is not a vast, empty expanse of isolated stars and planets. Instead, it is a dynamic and interconnected network with objects constantly moving between stars, carrying with them the potential for discovery. This realization expands the boundaries of the solar system and suggests that the galaxy is far more active than we ever imagined. Moreover, the presence of these interstellar objects raises the possibility that our solar system may not be the only one with occasional visitors from other star systems. Could other civilizations, other worlds be receiving their own interstellar travelers? The possibility that 3I Atlas is not unique but part of a larger pattern of cosmic activity invites us to think on a cosmic scale. Just as we send out spacecraft to explore distant planets and moons, could there be other civilizations out there sending their own probes to explore the star? And could these visitors, like 3I Atlas, be the key to unlocking a broader understanding of the universe? The search for cosmic connection. The arrival of interstellar objects into our solar system compels us to reconsider the scale of human exploration. Up until now, we have measured the distances between stars in light years, assuming that the distances between solar systems are too vast for practical exploration. But the presence of interstellar objects suggests that cosmic travel may be more common than we think. These objects may be the result of forces beyond our control, or they may be the products of intelligent design sent to explore the galaxy in ways that we have yet to understand. Could these objects be part of a larger effort to map the universe, to explore distant star systems and send back information? Are we merely the recipients of a greater cosmic journey, one that spans billions of years and countless civilizations? The presence of interstellar visitors challenges our assumptions about our place in the universe and invites us to consider the possibility of cosmic connection beyond our current understanding. A new frontier in astrophysics, the discovery of 3I Atlas and other interstellar objects, marks the beginning of a new frontier in astrophysics. These objects force us to rethink everything we know about the structure and dynamics of our solar system and the galaxy at large. They challenge traditional views of space as an empty, isolated expanse and open up the possibility of a much larger, interconnected universe teeming with movement and interaction. As we continue to study these interstellar visitors, we may uncover new insights into the forces that govern the cosmos, and in doing so, expand our understanding of the universe's true nature. By exploring the movements and trajectory of these objects, we are also exploring the very boundaries of human knowledge, confronting questions about space, time, and the forces that shape our existence. The universe is far more vast, complex, and interconnected than we ever imagined. And as we push the boundaries of astrophysics, we may one day discover that the universe is not a collection of isolated systems, but an intricate web of cosmic travelers, each one carrying with it the potential for discovery and perhaps even a glimpse into the mysteries of other civilizations. Is there a hidden message? Theory of alien communication. The idea that 3I Atlas might be more than just an ordinary comet, perhaps an interstellar message, offers an intriguing possibility that lies at the intersection of scientific inquiry and speculative imagination. Could the anomalous object be more than just a cosmic wanderer? Could its strange trajectory, unique shape, and unexplained acceleration be an intentional signal from an advanced extraterrestrial civilization? This question taps into humanity's deep desire to understand our place in the universe and the potential for communication with other intelligent beings. From the search for extraterrestrial intelligence, SETI, to science fiction narrative, the possibility of alien messages has long captured our collective imagination. But what would alien communication look like, and how might we recognize it? The history of alien communication. Humanity Humanity has been fascinated with the idea of communicating with extraterrestrials for centuries. Early speculations were rooted in myth and religion, with stories of gods descending from the heaven, but modern efforts to make contact have focused on more scientific and practical methods. The most well-known of these is the search for extraterrestrial intelligent SETI, which uses powerful radio telescopes to scan the cosmos for signals from advanced civilization. Since the 1960s, SETI has monitored the skies for any signs of deliberate communication, seeking patterns in radio waves that might indicate the presence of intelligent life. In 1974, scientists at the Arecibo Observatory in Puerto Rico sent out the first interstellar message, a binary encoded signal aimed at the star cluster Messier 13. This message, known as the Arecibo message, was a simple attempt to introduce humanity to any potential extraterrestrial listeners. It contained information about human beings, our DNA structure, the solar system, and our technology, all encoded in a way that would be understandable to an alien intelligence with similar technological development. While we have yet to receive a reply, the message represents a concrete example of the kind of signal that could be sent by an advanced civilization. Similarly, the Voyager spacecraft, launched in 1977, carries the famous golden record, a phonograph disc containing sound and images intended to represent the diversity of life and culture on Earth. This, too, is an attempt to communicate with any extraterrestrial civilization that might one day encounter the spacecraft, which is now the farthest human-made object from Earth. Like the Arecibo message, the golden record is designed with the hope that intelligent life forms will understand its content despite the vast distances and potential differences in cognitive ability. Yet, despite these efforts, we have received no definitive signal from extraterrestrial civilization. The question remains, how would an alien civilization choose to communicate with us, and how could we recognize the possibility of a cosmic message? Enter 3I Atlas. The object's bizarre behavior, its hyperbolic trajectory, unexpected acceleration, and unusual shape has led some to wonder if it could be a deliberate signal from an alien intelligence. Unlike the traditional search for radio signal physical probe, 3I Atlas would be a message encoded not in sound or light, but in its very existence. Its movement through space and its interaction with our solar system could be interpreted as a form of cosmic communication. This idea is not as far-fetched as it might seem. If an advanced civilization were attempting to make contact, they might choose to send a message in a way that is not immediately recognizable by conventional scientific methods. After all, our own attempts to communicate with potential extraterrestrial have been based on the assumption that they would understand our form of technology, our method of encoding information. But what if alien civilizations think differently, using methods of communication that transcend our current understanding of physics and technology? What if the message is hidden in plain sight, disguised as something we would interpret as a natural phenomenon, like a comet, yet its characteristics point to something intentionally designed? Some researchers speculate that the strange shape of 3I Atlas, a long cigar-like form, could be a form of intentional design, something that an alien intelligence might have created to serve a specific purpose. Perhaps the shape is designed to reflect light or radiation in a way that maximizes visibility as it passes through our solar system. Could it be a cosmic beacon, a signal that we are meant to observe but are not yet equipped to understand? The trajectory of 3I Atlas is equally suggestive. Its hyperbolic orbit, the fact that it is not bound to our solar system, could indicate that it is not simply a random interstellar object. Rather, it could be intentionally placed on a path through our solar system, drawing attention to its arrival. The fact that it came from outside the solar system, traveling at an extraordinary speed, suggests that it is not part of the normal cosmic traffic. If 3I Atlas is indeed an intentional signal, it would represent a form of communication that is in many ways more sophisticated than any radio transmission or physical message we could send. Science fiction meets science, the concept of alien communication through objects like 3I Atlas is a theme often explored in science fiction. From Arthur C. Clarke's Monolith 2001, A space odyssey to the mysterious alien artifacts in Contact by Carl Sagan, science fiction has long pondered the idea that extraterrestrial intelligence might communicate in ways that are beyond our comprehension. In these fictional works, the message is often embedded in an object, hidden in plain sight, waiting for the right moment to be uncovered by a curious or intelligent species. In some ways, 3i Atlas mirrors these science fiction's concept. It is an object that defies explanation, provoking speculation and wonder. Its odd shape, unexpected behavior, and strange speed are qualities that, while not conclusive, hint at the possibility that it is more than a random comet. It offers the tantalizing prospect that we might be on the verge of discovering a message from the stars, one that could reshape our understanding of the universe. However, there is a fine line between speculation and scientific rigor. While the idea that 3i Atlas is a deliberate signal is fascinating, it remains just that, speculation. The scientific community has largely approached the object as a natural phenomenon, exploring explanations ranging from gravitational interaction to outgassing to the influence of unknown cosmic forces. For now, no evidence supports the theory that it is an alien message. Yet the very fact that we are asking the question suggests that we are not far from crossing a threshold into a new era of exploration, one where the line between the speculative and the scientific becomes increasingly blurred. Technological limitations and the search for meaning. The possibility of alien communication raises fundamental questions about our ability to detect and interpret such signals. The technologies we currently use to search for extraterrestrial life, radio telescopes, space probes, and even artificial intelligence are all products of our own limited understanding of the universe. While they allow us to explore the cosmos in unprecedented ways, they also constrain us by focusing on method of communication that we understand. If extraterrestrial civilizations use forms of communication that are radically different from our own, we may not even recognize them when we encounter them. This is where the search for alien messages becomes as much about expanding our imagination as it is about expanding our technology. The challenge is not just in developing more advanced tools for detecting signals, but in cultivating a mindset that allows us to think beyond our current knowledge. If 3i Atlas is indeed a message, it may not come in a form that we immediately recognize. It may require new theory, new frameworks, and a new way of understanding the cosmos, one that embraces the speculative and the unknown. The philosophical implication. What does it mean? The question of whether 3i Atlas is an intentional signal forces us to confront some of the deepest philosophical questions about our place in the universe. If we are not alone, what does that mean for humanity? How would contact with an extraterrestrial civilization reshape our understanding of life, intelligence, and the universe itself? The very idea that a message could be embedded in an object like 3i Atlas invites us to think about the nature of communication in ways we have never before considered. If 3i Atlas is a message, it could be the beginning of a profound transformation in human thought. It would suggest that the universe is teeming with intelligent life and that civilizations across the stars are sending messages, whether we recognize them or not. It would force us to reconsider our role in the cosmos and our responsibility to understand and engage with the greater galactic community. The implications of such a discovery would be nothing short of revolutionary. The Fermi paradox. Where are the aliens? The question has echoed through the halls of scientific inquiry and the corridors of human curiosity for centuries. If the universe is so vast with billions of stars and countless planets, why haven't we encountered alien life? This question, known as the Fermi paradox, was first popularized in the mid-20th century and remains one of the most profound and perplexing dilemmas in the search for extraterrestrial intelligence. SETI, the paradox, named after the physicist Enrico Fermi, captures the tension between the high probability of intelligent life existing elsewhere in the universe and the absolute lack of evidence for such life. It presents a fundamental contradiction. If alien civilizations are out, why haven't we found them? In this context, 3i Atlas, an interstellar object that passed through our solar system in 2019, becomes a key point of focus. Could it be that this enigmatic comet is the first tangible evidence that we are not alone, a glimpse of an advanced civilization just beyond our reach? Or is it merely a cosmic coincidence, a fleeting object whose strange behavior can ultimately be explained by natural? This section explores the Fermi paradox through the lens 3i Atlas, grappling with the tension between the tantalizing possibility of alien life and the stark reality of our lack of direct contact with it. The scale of the universe, why it shouldn't be empty. The vastness of the universe has long been a powerful argument in favor of the existence of extraterrestrial life. With over 100 billion stars in the Milky Way alone and an estimated 100 billion galaxies in the observable universe, the odds seem overwhelmingly in favor of the existence of other planets capable of supporting life. Many of these stars are likely to have planets within their habitable zones, regions where liquid water could exist, fundamental requirement for life as we know it. Thousands of exoplanets have been discovered in the past few decades, many of them Earth, suggesting that the conditions for life are not unique to our planet. Given these astronomical numbers, the probability of Earth being the only planet with intelligent life seems almost absurd. Yet, despite this seemingly high likelihood, we have encountered no concrete evidence of other civilization, no radio signals, no artifacts, no visitors from the stars, no direct confirmation that we are not alone in the universe. This brings us to the crux of the Fermi paradox. The universe, with its mind-boggling size and number of potentially habitable planets, should be teeming with life, yet we've seen no signs of it. If advanced civilizations exist, why haven't they made themselves known? And if they have, why haven't we detected their presence? The great silent, possible explanations for the paradox. There are several theories that attempt to explain the Fermi paradox, but none provide a definitive answer. Some of these explanations are rooted in the idea that alien civilizations might be out there, but for reasons unknown, they remain silent, either by choice or due to unforeseen circumstance. Here are a few of the major theories. The rare Earth hypothesis. One of the most commonly proposed solutions to the Fermi paradox is the rare Earth hypothesis, which suggests that while microbial life may be common throughout the galaxy, the conditions necessary for the development of complex, intelligent life like ours are exceedingly rare. According to this view, Earth is an exceptional case with a unique combination of factors such as its position in the habitable zone of a stable star, its relatively large moon, and the protection of its magnetic field. These factors may have combined to create the conditions necessary for intelligent life. If this hypothesis is correct, it would explain why we have not encountered any alien civilization. They are simply far rarer than we think. The Great Filter. Another possibility is that a great filter exists, a barrier that prevents intelligent civilizations from reaching an advanced communicative stage. This filter could occur at any point in a civilization's development, from the emergence of life itself to the development of intelligence to the ability to communicate across interstellar distance. If the great filter is behind us, this would mean that Earth's civilization has already passed the hardest stage and we are incredibly rare in the universe. But if the great filter lies ahead of us, it would mean that the survival of advanced civilizations is rare and that most civilizations destroy themselves before they are able to communicate or travel across the star. The absence of extraterrestrial signals might thus reflect a pattern where intelligent civilizations tend to self-destruct long before they can make their presence known. Civilizations are too distant in time. A more optimistic solution that alien civilizations might simply be too distant in both time and space to detect. If extraterrestrial civilizations exist, they may be millions of years ahead or behind us in their technological development. Even if some civilizations have achieved the ability to travel between stars, the vast distances between solar systems may make contact incredibly difficult. Perhaps alien civilizations have already risen and fallen, leaving behind only faint traces that we are unable to detect. Conversely, perhaps we are on the cusp of reaching a level of technology that will allow us to communicate with them if they still exist. We are not looking the right way. Another theory is that alien civilizations are trying to communicate, but we are simply not looking in the right way. Our methods of detecting extraterrestrial life are based on assumptions that might not hold true for all civilizations. We look for radio signals, for example, assuming that alien technologies would use similar communication methods to ours. But what if alien civilizations use completely different technologies, ones that are beyond our current
understand?
Perhaps they are sending signals that we cannot yet detect, or they might be using forms of communication that don't rely on electromagnetic waves. The Great Silence might not be a sign that aliens are not out there, but rather a sign that our search methods are too limited to find them. Atlas, a potential clue in the paradox. Enter 3I at this strange interstellar object that passed through our solar system in 2019 provides a compelling twist on the Fermi paradox. Could it be that 3I Atlas is the first concrete evidence that we are not alone in the universe? Its hyperbolic trajectory, inexplicable acceleration, and unusual shape make it an anomaly that challenges our understanding of natural objects in the solar system. Could these features suggest that 3I Atlas is not a natural comet, but a deliberate message or probe sent by an alien civilization? The possibility that 3I Atlas is an artifact from an advanced civilization, perhaps an interstellar probe or a deliberate signal, offers an intriguing potential solution to the Fermi paradox. If this object is truly an alien probe, it would suggest that civilizations are indeed capable of interstellar travel and communication. But the absence of any other similar object and the difficulty in interpreting its purpose points to a key tension in the Fermi paradox. Even if aliens are out there, they might not be sending signals in ways we expect, or they may not be sending them at all. Could 3I Atlas be the first of many signals from alien civilization, each one so subtle that we're only now beginning to recognize? Or could it be a solitary anomaly, a one-off event that proves the exceptional nature of Earth's own place in the universe? The object's passage through our solar system offers a tantalizing clue, but it leaves many unanswered questions. Cosmic coincidence or evidence of life? The question that remains is whether 3I Atlas is a cosmic coincidence or evidence that we are not alone. The object's unexplained acceleration and trajectory could be a natural phenomenon that we simply do not yet understand. Perhaps it is a comet from a distant star system influenced by gravitational forces in ways that are beyond our current models of astrophysics. Alternatively, the object's strange behavior could be a sign that we are on the cusp of discovering something truly profound, a signal from the star waiting to be decoded. The Fermi paradox has always been an open question, one that may never have a definitive answer. But as we study objects like 3I Atlas, we are forced to confront the tension between the vast, empty silence of space and the possibility that it may not be empty at all. The paradox remains unsolved, but each new discovery, each strange object like 3I Atlas brings us one step closer to understanding the nature of the universe and our place within it. Could we be on the verge of finding the answer to the greatest question of all, or will we continue to search in silence, just one small part of an infinite universe, waiting for a message that may never come? The consciousness question: could aliens think different? The quest to understand extraterrestrial intelligence is not only a question of whether we can find alien life, it's a question of how that life might think, perceive the universe, and experience consciousness. As we explore the possibility of intelligent alien civilization, one of the most profound challenges we face is this: could aliens think differently from us? Could their consciousness be fundamentally unlike anything we can imagine? When we consider extraterrestrial intelligence, we often do so through the lens of our own human experiences. We assume that alien life, if it exists, must be like us, in some way capable of reason, emotion, and communication, just as we are. But what if the forms forms
of consciousness found in the cosmos, so different from ours that we cannot even begin to understand them.
This section explores the nature of alien intelligence and consciousness, contemplating the vast possibilities for how extraterrestrial beings might perceive and interact with the universe, and how these differences challenge the limits of human understanding. The limits of human understanding. Human beings, we are conditioned to view the world through a particular lens, a lens shaped by our biology, our sense, and our limited cognitive ability. We experience reality through sight, sound, touch, taste, and smell, and we interpret the universe based on these senses. Our understanding of the world is shaped by human reason, logic, and the constraints of our physical form. But this view of reality is inherently narrow, and it might not be applicable to alien forms of life that operate under completely different conditions. The most fundamental question is this: how do we define consciousness? For us, consciousness involves awareness of ourselves and the world around us, the ability to think, reason, and feel emotion. It is deeply tied to our biology, particularly to our brain and nervous system, and it depends on complex biochemical processes that we understand only partially. But what if alien consciousness doesn't rely on biological structures at all? What if it is based on something completely different, something beyond the limits of our understanding? Alien cognition and sensory perception. One possibility is that extraterrestrial beings could perceive the universe in ways we cannot imagine. Their senses could be radically different from ours. For example, what if an alien species sees electromagnetic fields or perceives time not as a linear progression but as a fluid, non-linear phenomenon? What if their experience of reality is not grounded in visual or auditory stimuli, but in a sense we cannot comprehend, like the ability to detect quantum fluctuations or the ability to sense other dimensions? Consider, for instance, how life on Earth thrives in environments that would be inhospitable to humans. Some species of animals are capable of perceiving ultraviolet or infrared light, while others navigate through echolocation or use electric fields to communicate. These are different ways of seeing the world, ways that we as humans cannot fully understand because our biology does not support these forms of perception. Now imagine an alien species whose sensory modalities are so different from ours that we cannot even begin to fathom how they experience the universe. Their concept of reality might be completely alien to our own, governed by different laws of perception, sensation, and thought. Cognitive structures, different mind, different thoughts. Beyond sensory perception, there is the question of how alien might think. Could extraterrestrial beings process information differently, with cognitive architectures that are fundamentally different from our own? The human brain is an organ shaped by millions of years of evolution, optimized for specific tasks, survival, social interaction, language, problem solving. But what if an alien civilization has evolved on an entirely different planet under conditions that favored a radically different mode of cognition? In recent years, scientists have speculated that an alien species might have a fundamentally different approach to problem solving, learning, or even memory. For example, some theorists suggest that aliens might process information collectively, with many individuals in a species functioning together as a kind of distributed intelligence. Instead of thinking in terms of individuals, their cognition might involve the entire species working in unison, much like a hive mind. Such a concept challenges our understanding of individuality, consciousness, and intelligence, suggesting that aliens could experience the world as a shared collective consciousness, not as isolated independent entity. Another possibility is that aliens could have a form of intelligence that is based on entirely different principles. We are familiar with carbon-based life, where organic molecules serve as the building block of cognition. But what if extraterrestrial life is silicon-based, or even something even more exotic, like life forms that use quantum computing as the foundation of their cognition? Quantum consciousness, a theory that has been explored in the field of quantum physics, suggests that the brain might function as a quantum computer, processing information at a much higher rate of speed and complexity than classical computers. What if an alien species evolved to use quantum mechanics to power their cognition? Their mental processes could be so far beyond our own that we would struggle to even comprehend them. The problem of communication: if alien minds think differently from ours, then communication with them could be far more difficult than we imagine. As humans, we rely on language to communicate, a system of symbols that is tied to our biology and our way of thinking. We also rely on shared concepts and experiences to understand each other. But if aliens think in ways that are fundamentally different from us, how would we bridge the gap? Could we even hope to communicate effectively? This is a core challenge of the search for extraterrestrial intelligence. For decades, the SETI program has searched the skies for radio signals from distant civilization. But what if aliens are not sending signals in a form we understand? What if they are using methods of communication that are entirely outside of our experience, something that doesn't involve electromagnetic waves or even physical signals, but instead relies on the direct transmission of thought or manipulation of space-time itself? In the 1980s, Carl Sagan and others proposed that should we ever make contact with an alien species, it would likely involve a form of communication far more advanced than anything we can currently imagine. One possibility that Sagan suggested was that aliens might communicate through the manipulation of physical phenomena, such as gravity and light. Could 3i Atlas be an early form of such communication? Perhaps its strange trajectory, speed, and structure are not just a random occurrence, but the product of an advanced civilization attempting to communicate with us in a way that we cannot yet comprehend. Theories beyond the physical. Moving even further into the realm of speculation, some thinkers have proposed the idea of cosmic consciousness, the notion that the universe itself is conscious, or that consciousness is a fundamental feature of the cosmos. This concept, which has been explored by philosophers and physicists alike, suggests that intelligent life might not be limited to individual beings, but could be a property of the universe itself. If this theory is correct, then extraterrestrial intelligence might not exist as discrete entity, but as part of a universal consciousness that spans across space and time. What if alien civilizations have learned to tap into this cosmic consciousness? What if their forms of thinking and communication are so advanced that they no longer need to rely on the physical world for their existence? They could be living in ways that transcend space-time, interacting with the fabric of the universe itself. In such a scenario, an object like 3i Atlas might not be a physical probe, but a manifestation of a consciousness that exists beyond the material realm, perhaps a beacon or a marker placed in our solar system to make us aware of this greater universal intelligence. The limits of human imagination. As we consider the possibilities for alien intelligence, we are reminded of the limits of our own understanding. Our conception of consciousness is tied to our biology, our senses, and our perception of the universe. But the truth is that alien consciousness could be so different from ours that we can hardly begin to imagine it. Whether they perceive the universe through entirely different senses, think in ways that are beyond our comprehension, or communicate using methods we have yet to discover, the possibilities are endless. As we search the stars for signs of alien life, we must remain open to the idea that alien intelligence may be so different from our own that it defies all our expectations. The very nature of consciousness itself may be a mystery waiting to be unraveled, not just in our own minds, but in the minds of the beings that inhabit the vast expanse of the cosmos. In contemplating the nature of alien intelligence, we are not just seeking to understand others, we are also forced to confront the limitations of our own understanding of what it means to be conscious, to think, and to experience reality. The search for extraterrestrial life may not only lead us to new forms of life, but also to new ways of thinking about what life and consciousness truly are. What does 3i Atlas tell us about the universe? As 3 Atlas made its way through our solar system in 2019, its fleeting presence sparked both awe and deep contemplation among astronomers and the general public alike. Whether it is a comet, an interstellar probe, or something else entirely, 3i Atlas has become a symbol of the mysteries that remain at the very edge of our understanding. And in its journey across the cosmos, it raises a question that is as old as humanity itself. What does this strange visitor from the stars tell us about our place in the universe? The object's strange trajectory, its inexplicable acceleration, and its unusual shape have all defied easy classification. For many, these anomalies immediately conjured the possibility of extraterrestrial intelligence, an idea that has captivated our collective imagination for centuries. Yet, even as we entertain entertain the possibility that 3i Atlas might be evidence of an alien civilization, we are left with just as many questions as answers. Could it be a signal, a probe, a message of cosmic proportion, or could it simply be a natural phenomenon we do not yet fully understand? Regardless of its origin, 3i Atlas has become a mirror reflecting not just the vastness of the cosmos, but our own place within it. The object is, in many ways, a metaphor for the human condition. It is a symbol of our enduring curiosity, our drive to understand the universe and our place in it. And in its mystery, it forces us to confront the very limits of human knowledge and perception. As we look out into the cosmos, we are reminded of how little we truly know and how much there is still to discover. The search for meaning in a vast universe. When 3i Atlas first crossed into our solar system, it was, in many ways, just another object, another comet or asteroid that passed through the vast emptiness of space. But the more we learned about it, the more it became a symbol of something much deeper. It challenges us to ask, what if the universe is not the empty, inhospitable place we have often assumed it to be? Instead of a void, the cosmos might be teeming with hidden messages, signal, and life waiting for us to discover. Atlas invites us to reflect on the human desire for meaning and connection. As a species, we've always looked to the stars, seeking answers to questions that go beyond the material world. What is our place in the universe? Are we the only intelligent beings, or are we just one of many civilizations scattered across the vast expanse of space? These questions have shaped our history, our science, and even our philosophy. And as we consider the possibility that 3i Atlas might be a message from another civilization, we are reminded that our search for meaning in the universe is as much about the journey as it is about the destination. The limits of knowledge and the infinite possibilities of the cosmos. One of the most profound lessons 3i Atlas is that the universe is far more complex and mysterious than we can possibly imagine. We often think of ourselves as being at the pinnacle of knowledge, of having uncovered the laws of nature that govern the cosmos. Yet, in the face of something like 3i Atlas, we are forced to confront how much we still don't know. The comet's strange behavior and the many unanswered questions surrounding its origins remind us we are only beginning to scratch the surface of understanding the universe's true nature. For all our scientific progress, we are still children in the face of the cosmos. And it is this humility that 3i Atlas provokes a reminder that even the most brilliant minds among us are limited by the tools, knowledge, and perspectives of our time. Yet rather than discouraging us, this realization should inspire us to keep searching. The universe is a vast, uncharted territory, and we are explorers in the most profound sense of the word. The role of curiosity, human progress, and cosmic wonder. Humanity's enduring curiosity about the universe is one of our greatest qualities. It is the driving force behind scientific inquiry, the exploration of space, and the quest for knowledge. And in many ways, 3i Atlas represents the culmination of this curiosity, an object that has sparked debate, theories, and questions that stretch the boundaries of science and philosophy. But curiosity is not just about seeking answers, it is also about embracing the mystery. It is about allowing ourselves to be awed by the unknown and to acknowledge that not every question has an immediate answer. In the search for extraterrestrial life, in the study of interstellar objects, and in the contemplation of the cosmos, we are reminded that some of the greatest discoveries happen when we embrace the questions themselves, not just the answers. As we look out into the stars, we are not just searching for evidence of life, we are searching for something deeper, something that connects us to the universe and to the mystery of existence itself. A philosophical reflection. What does it mean to be human? The arrival of 3i Atlas, whether it's a comet or something more, challenges us to reflect on what it means to be human. The more we explore the universe, the more we begin to see how fragile and small our existence is in the grand scheme of things. Yet at the same time, it highlights the incredible potential of human curiosity and creativity. The pursuit of knowledge, the drive to understand our place in the universe, and the desire to connect connect with something beyond ourselves are what make us human. In some way, Three-Eye Atlas serves as a reminder that we are part of a much larger, more intricate cosmos. We are not alone in the universe, but we are part of an ever-expanding narrative that stretches back billions of years and will continue long after we are gone. The object reminds us that while we are just one species on one small planet, we are connected to the cosmos in ways that are beyond our comprehension. Whether or not Three-Eye Atlas's evidence of alien life is secondary to the broader lesson it imparts, the universe is vast, and we are only beginning to understand its true nature. The continuing search for life and meaning, the discovery of Three-Eye Atlas, has reignited the discussion about life beyond Earth and the potential for contact with extraterrestrial civilization. Whether or not this particular comet is proof of alien life, its presence in our solar system pushes us to think more deeply about the nature of life, consciousness, and the vast expanse of space. It compels us to continue asking the difficult questions that may never have definitive answers, but are worth asking nonetheless. The search for extraterrestrial life is not just a scientific endeavor, it is a philosophical and existential one. It is a search for meaning in a universe that can often feel indifferent to our existence, and it is a reminder that even as we strive to understand the cosmos, we are part of something far larger than ourselves, a grand, unfolding story of exploration, discovery, and wonder. In this sense, Three-Eye Atlas is more than just an object. It is a symbol of humanity's unending curiosity and our place in the grand, mysterious tapestry of the universe. Our journey of discovery in the Three-Eye Atlas, regardless of its origins, serves as a powerful symbol of humanity's quest for knowledge. It invites us to look beyond the limits of our understanding and to imagine what might be possible in the vast stretches of space. It challenges us to think differently about our place in the cosmos, reminding us that the universe is not something that can be easily understood, but something that demands our curiosity, our wonder, and our intellectual courage. Whether Three-Eye Atlas is proof of alien life, a scientific anomaly, or simply an unexplainable cosmic event, it will continue to inspire and provoke thought for generations to come. And in its mystery, we find a reflection of our own curiosity, a drive to explore, to understand, and to connect with the unknown. As we look to the stars, the journey of discovery continues, and with each step, we draw closer to the ultimate question: what does it mean to be human in the vast and boundless universe?